Okay, so now that we're getting a little more comfortable with our first collection or container called the linked list, let's back away and look at something a little more general across all collections. So it's an interface called iterable, and it allows you to implement something called an iterator or a cursor. And this is a pretty important topic in Java, but our book doesn't really cover it, so I put a couple of links on the class website to really good online resources that I'd encourage you to check out. Okay. But what is an iterator exactly? So as I said, an iterator is a cursor. That's another name for it. And this cursor points to elements in your collection, and the iterator knows how to move forward in the collection. So in the linked list, it would just follow the arrows. So it would start at the beginning, and then I would say next, and it would go here, and then I would say next, and it would go here, and I would say next, and it would go here. And eventually, it would get to the end. But this is useful in collections like keys in a hash map where you don't actually have a predetermined order that you could go through. Like, it's pretty easy for me to see how to follow the arrows here, but in general, I might want to have a collection. I say I just want to go through the elements one by one in some order, and this will provide a common interface for doing so. So let's first examine an iterator on a class, on a collection that's already in Java. So that's the Arraylist. And I know many of you have seen the Arraylist before. Some of you have even chosen to use it in your assignments, which is great. And I went over it in 173, but let's just go over it again real quick just so we're on the same page. So an Arraylist is like a flexible array. And you'll actually see how this works behind the scenes on Lab 5 as well. But now from a usability perspective, what it allows you to do is add elements on the fly. And it will adaptively grow or shrink to accommodate additions and deletions. So unlike an array, you don't have to, an array has a fixed size at the beginning. You say array is equal to new int number of elements, but here it can actually grow and shrink. So for example, it starts off empty, but I can add the first 20 integers. So I can say arrow.add I. And the other cool thing about the array list is, so in order to access an element, I have to say arrow.get, it's some index. So I can't index it directly like I would with an array. I have to go through this method, but that's okay. So I see that prints 10. But the really cool thing is, unlike an array, this class actually implements a toString. So if I print array, it'll actually output the elements of the array in formatted list format here. So that's nice. Okay, so that's an array list in a nutshell. And you'll, again, get intimately familiar with it on Lab 5. But now let's look at an iterator through the array list. Let's create a cursor that goes through this. So what I'll do is I'll just define something of type iterator. And it's an iterator of integers. I'll call it iter. That's pretty common. You'll see in code examples to call it iter. Equals array.iterator. So my array.iterator. So this sets up a cursor, and it'll set it up at the beginning. And what I can do is I can say loop through it. I'll say as long as there's something to go to next. So I'll say as long as iter.hasNext, so there's a hasNext method that says, can I still keep going, or have I, in the linked list example, eventually I'll run the end. So if I'm here and I say hasNext, it's not true. The cursor can't keep going. It would go off the end. But as long as I can keep going, I'll go to the next thing. So if I say the following, if I say int val equals iter.next, what this will do is this will return what's at the iterator. But then the result of this will be that the iterator moved on. So if I print val, then what I'll see is, okay, it starts off at the beginning at 0, because I'm just adding the numbers from 0 to 19. So it starts at 0. When I say next, it goes to 1, but it returns 0 before it does that. So I get to see where it was, and now it's moved on. But the other thing that I can do, which is kind of interesting, is I can actually mutate state. This is the technical term for it, but what it means is an iterator can actually take a more active role. It doesn't just have to passively loop through this thing, but it can actually delete things that were at that cursor. So I can say if val mod 3 is 0, then I'll say iter.remove. And that will remove where the cursor just, it'll remove the thing just before the cursor. So if I moved on to the next thing, if I see that where I just was divisible by 3, then I'll remove it. Okay. So watch this. If I now go ahead and print out the array list, what I'll see is that this removed everything that was divisible by 3. So if I go to the next thing and I say, hey, you know what? The thing I was just at was divisible by 3. Move the thing remove it. Remove the thing right before the cursor. Okay. So that's iterators in a nutshell. Although I have to say, from what I've seen, this is frowned upon. So you usually don't want iterators to mutate state. It can just make things a little more confusing. That's the reason. But the feature is there, and it's implemented in some classes that are iterable. Okay, but let's look at how to make our own iterator real quick. So I'm going to go back to the linked list. I'm actually going to make my own iterator and tell the cursor how to move along. Okay, so what I need to do actually is say, I'm going to make a class. So I'll say private class LL iterator implements iterator of type item. Okay, so I'm going to make my own iterator, and I'm going to define what next and has next do, how they work. So if I click implement all abstract methods, look, see, and actually even Java kind of discourages you from doing a remove. It doesn't check the remove by default, it just says, okay, let's try to implement next and has next. So I need to tell this thing how to go next, and I need to figure out how to tell it when it's done, when it's going to be done. So I'll just say private node cursor. And actually what I'm going to do is I'm going to make a constructor, and I'm going to pass along a linked list. And I'll store a reference to that linked list as a private variable here. So I'll say this.list equals list. And it's just because I'm going to need a reference. This iterator is going to be associated to a particular linked list. And I need to remember what that linked list is so I can look at it and see, well, what is actually next? Okay, but what I'll do is I'll start the cursor off as the head of the linked list. So what I'll do, so the cursor, in order for it to have a next, I have to say, well, return cursor is not null, and cursor.next is not null. Okay. So in the case that this is an empty list, it's not going to have a next. If it's not empty, I'll check this, then I'll make sure that the thing after where the cursor is not null either. Okay. So to get the next, I just say, so let me get a reference to the item. Item equals cursor dot value. And then I'll say cursor equals cursor dot next. And I guess to be really careful about this, what I'll say is, let me make item null by default. And I'll say if cursor is not null, then I will extract the item and I will go to the next thing. Okay, so this is not too bad because a linked list is pretty simple. It almost kind of what we want to do already. The arrows point us where to go next, so we just move the cursor along when you say next. Okay, but now notice back when I was in the array list, I actually had to generate a new cursor that started at the beginning by calling this method called iterator. So actually the class where I want to use the iterator on actually has to implement another interface, which is called iterable. So we made an iterator which implemented the iterator interface. And so that's the cursor. But now we need to, in order to use the cursor, we need to implement another interface called iterable. Okay. And so this actually just has one method, which is, as you saw with the array list, it's iterator. So this is going to return a new iterator which starts at the beginning. And so all we have to do is return a new LL iterator, and we'll be sure to pass along this. Okay, because remember it needs a reference to the linked list that it's being made on, and so it's being made on this linked list because this is the iterable linked list. So I pass along this. Okay. So now I can do a lot like what I did in array utils. I can actually almost just copy this code verbatim. I didn't implement the remove, but so if I copy it like this, I can say the iter is equal to list.iterator. And let me just go ahead and print system.out.print iter.next. Oops. And let's make sure that we're printing everything out and that we don't have any bugs. Okay, we do have a bug because it stopped too soon. I think what I meant to say here was actually while cursor is not null, that'll be enough actually. Yeah. Okay, so this is a little simpler than I had said. Okay, so this will take me all the way through. And as soon as I'm at the end, it'll stop. Okay, so that's really all there is to iterators. It's like kind of a lot of stuff floating around here. You know, we make our own iterator, which is a cursor which holds a reference to something. That has to implement the iterator interface so we can define how to, whether to see if we're at the end and also to go to the end, element by element. But we also have to say, well, I need you to make an iterator in this class. So that means it needs to implement iterable. And so I'm going to have to return an iterator. But you see, this is all pretty simple for the linked list. I'll have you make an iterator on assignment 3 just for some practice with this. But it's really not too bad. Again, it's just to make a standardized interface. So see, look, I was almost able to just copy and paste the code. Even though an array list and a linked list are pretty different, I can iterate through them using the same interface. So this is another type of code sharing. If you made an algorithm that worked on a general collection and just needed to go through things in order, you could have code that looks like this and uses an iterator. And now it doesn't matter if I use an array list or this linked list I just made, the code will work just the same. Okay. Now, honestly, I don't actually feel like you need to do an exercise if you got this. The exercise will really be the assignment. But I would like you to study this code and come to class with any questions that you have on it on Friday. But otherwise, on Friday, we're just going to work on the lab and the next assignment. Okay? And maybe we'll see, I'll have you implement an iterator in the array list, but I don't really think that's necessary. Okay, so we'll see. All right, so thank you for your attention. I'll see you on Friday.